So it is my great pleasure to introduce Tracy King, who's our invited speaker this morning. I'll say a few words about Tracy's history. So Tracy got her PhD at Stanford in linguistics in Slavic case.
Word order,
Slavic, but Slavic, right? She did she was a Fulbright lecturer in Georgia, Tbilisi. She came to the natural language group at Xerox PARC about 20 years ago, so we've been colleagues and collaborators for quite a long time. She came at a very significant moment for the LFG community. Before that, in the late 70s and in the 80s, the formal structure architecture of LFG was developed in the 70s, and then linguistic interpretation, lots of linguistic analyses within the framework, and the algorithms for parsing and generation had been developed also. And we decided in the early 90s that it was time to take the theoretical view of LFG and actually use it to do real linguistic, large-scale grammar work, and to ask the question whether or not a theoretically defined approach to language could actually have practical consequences. And that's when we created the Pargram project, which many of you have participated in, and I hope most of you have at least heard about. So Tracy came to work to Xerox to work on the English grammar and became the prime developer of that grammar. In fact, she moved up the ranks and became the chairman of the feature committee, which is a very prestigious and powerful position.
I mean co-chairman.
Well,
that's
there's some
view.
people that think they have. And she became actually really the go-to person for many activities, many grammatical problems that showed up in a lot of different languages, became really the central pole of the community, and made these very significant contributions to LFG practice and LFG theory, which is what I think she's going to talk about today. She's also been an incredibly productive collaborator. There's so many papers that she has been a co-author of, if not an author of, that we're thinking of creating this thing like the Tracy King number, like an Erdos number, to keep track of how close you are to the source. So today she's going to talk about this connection between theoretical linguistics and grammar engineering, which is really this discipline that she's been a prime mover of. And I haven't even mentioned all the managerial stuff and the roles that she's played in really pushing forward linguistic technology in a very practical and industrial setting. So, but with that, Tracy.
Okay, thank you, Ron.
Turn this off.
Yep, there we go. So I think one of the things that makes LFG and HPSG really special is that they're, in addition to the large, formal and theoretical body of work. Okay, is that better? Okay. There's also a large grammar engineering community which takes and produces these, implementations of the theory, and they're true implementations of the theory. They're not, stochastic probabilistic processes that produce representations that sort of look like the theory. You're in fact writing, for example, C structure and F structure rules in LFG that really look like the LFG rules. And as I was thinking about what all, I had done and the LFG and HPSG communities had done, I realized there are a number of ways in which these cross, and I wanted to discuss some examples from each of the ways, so that whether you're only doing theoretical linguistics, you might think, oh, some of these could be useful to me, maybe I want to collaborate with someone, and try some of these out. Or if you're really only doing the grammar engineering, you might want to think, are you doing things that perhaps you should feed back to the theoretical community? And I have 4 different examples. We might only get through 3 of them. but we'll see exactly how fast we go through these. And there is no quiz at the end that you understand the examples. I wanted to give you sort of a flavor of what was there, and the examples all come from published works, I think the authors of which are all in this room. So if you do want more details, you can go and talk to them afterwards. But first, I think one interesting thing that shows in both LFG and HPSG how tightly tied these communities are is that there are these programs and large projects that are across institutions for doing grammar engineering, both LFG Pargram and HPSG in the Delphin and grammar matrix world. And interestingly, they seem to both have the same underlying reason for existence. So one of them is to sort of test the tenets of the theory, and in particular looking at universality, not just does what you propose work just for English or just for Walpurgi, but can you in fact sort of try these out and figure out is what you're proposing for one language going to work across a broad set of languages. And also to try to not just build small toy grammars, which you'll see I actually think have a lot of use to the community, but to really build up resources that you could then use in applications to see where do we really, in the more natural language processing community, need these deeper representations, which I think everyone in this room agrees are very important. But the question is, other than for our understanding of language, what are they useful for? Okay. And I'll say a little bit about each one of these for people who may only be familiar with one of the two. So pargram stands for parallel grammar. There's also a parsem, which builds up parallel semantics. So for those of you in HPSG and LFG, often pargram focused really on the syntactic structure to begin with and only later introduced the semantics. While in much of the HPSG grammar engineering, you'll see that the semantics is in fact much more tightly tied from the original. So pargram started with English, German, and French, which, as you might note, are not very typologically diverse languages. But we wanted to sort of see how much could we build up representations, functional structures that were similar across the languages, and where did they have to be different? And then added languages like Japanese and Turkish to the set, which are much more typologically diverse. There was always a lot of discussion of linguistic issues and what the analyses should look like, and could they be the same. Adjectives, copulars, negation, auxiliaries, and coordination were ones that occurred over and over again on how we should do these. There were also issues that were really forced by the grammar engineering environment, like what exactly does the morphology syntax interface look like, because we didn't want to list the full forms of every Turkish word in the lexicon because it's just not feasible. So this is of concern to the theoretical community, but the grammar engineering really forced the issue. And ambiguity, which came up in one of the theoretical talks earlier in the conference, it's just everywhere when you're building up grammars for these, and so that's something you have to address. For the Delphin and grammar matrix, this is largely from talking to Emily and copied off of the website. The idea is in some ways very similar. You're building up broad coverage, precision grammars for a large number of languages. And the precision here is not in some ways relevant for this community, but it's arguing sort of against some of the more standard practices in the natural language processing world these days, where there isn't any real conception of grammaticality. So you can view precision here as only parsing things that are grammatical and rejecting things that are ungrammatical. Part of the goal was they had a few large existing grammars. How can you use these to help build up newer grammars so that it's much faster if you want to build a grammar for a new language? Similar to the parallel functional structures, they're using a common minimal recursion semantics format. And this is also a way to exchange data and analyses of phenomena, so going back sort of more to the theoretical world. And interestingly, there is a goal to build up tools for field linguists to help test hypotheses and encode their results. I do not know how far things have gone there, but I think that's an interesting idea of what you can do with grammar engineering to help the more general theoretical world. So the first use case for grammar engineering that I wanted to actually discuss is the one that within Pargram and Delphin we think of the least, which is actually you're working in theoretical linguistics, you have some analysis, and you want to really confirm whether it works or not. And so this is a sort of a low-effort grammar engineering way. You can't do this for everything because the platforms sometimes don't implement something you want to work on. So in LFG, if you want to do a lot of work on linking theory, that's not a good thing to do this for. But I'll show you an example where we did use this. Ironically, though, my first example of where this was done is Mary, Miriam, and Annetta did do this for one of their linking theory proposals, but it's not in the broad coverage grammar. Ash has done this for resumptive pronouns. You saw a reference to this earlier. Lots of Bertold's work started out in this way of taking things like house of tone and figuring out, implement it, see does it really work. And last year in the LFG conference, Oleg, Mary, and John had an adjective coordination paper that was of this type. You have an analysis, you want to implement it to see, are you really able to get all the cases that you want done? So here, the example I chose for this to talk about is a paper that Louisa, Mary, and I did on indeterminacy by underspecification. So our question was, how do you formally encode indeterminacy? So people who in 2009 were paying attention to our presentation, you can tune out for the next few minutes. So indeterminate forms are really interesting because they can simultaneously satisfy conflicting requirements. So here we're going to focus on case, forms that appear to really be two cases at the same time. So it's not some form that is either accusative or dative, but in fact is both accusative and dative at the same time. And what we proposed is that the values of these features is actually a complex structure. And what makes you indeterminate is the fact that your structure is underspecified. There will be a diagram. And you can incrementally and monotonically build up the structure of these. And they have only atomic Boolean valued features. And I won't show this here, but it covers indeterminate arguments and predicates. So I will not be reading the German examples and embarrassing myself here, but an example of an underspecified indeterminate case comes from the word for parrot in German, in the plural, where this form is nominative, accusative, dative, and genitive basically at the same time. So this is not an or. It turns out this really is all of these forms. Okay. So how do we know this? So this form can occur after a verb that requires the accusative. I did not show the data, but if you put in, say, a pronoun, you can see that this verb find really requires an accusative. Parrots can appear after that. And it can appear after a verb that requires the dative, like help. But interestingly, it can occur as the object of coordination of both of these verbs. So you can have he finds and helps parrots, where parrots here has to be both accusative and dative. And it turns out this is actually hard to do. So what did we basically propose? We propose that forms that are really accusative in German look like what you see on the top left there. So you have an accusative value that is plus, and everything else is negative. This means you can only be accusative. Similarly for dative, you have a plus value on the dative, negative on everything else. But these indeterminate cases simply have no values. So it's not that those have negative values. The values in the lexicon are underlyingly unspecified. And what happens is things like adjectives and verbs will provide further specification for what the values are in any given construction. So for example, when you have a verb like help, which takes a dative, all it's doing is saying my object takes a dative. It's not saying my object has to be negative on nominative. It just says put a plus on the dative. The accusative is the same, didn't show that one. So what happens when you have find and help and one of these indeterminate nouns is that find is going to put the accusative plus, help will put the dative plus on there, and the structure will be fine. And for those of you who aren't used to the LFG notation, this object here, the little f structure, is shared across with the object of help, and I just showed this by indexing to make it a little easier. Usually you draw a curved line for those who are used to the usual representation. Okay, so basically you've got one form, it is both accusative and dative, and this only can happen on these indeterminate nouns. Okay. But it turns out sometimes you're forced by something like this adjective old, which says it really is dative. When you put it with this form of old with the parrots, it actually forces the dative. So what does this mean? This means Alton is putting in nominative minus, accusative minus, and genitive minus on the form parrots. When you then try to combine this with the accusative taking verb find, it's ungrammatical. And that's how you get the ungrammaticality of the entire form. Okay? Now, this leads you to believe, what if you found an adjective that itself was indeterminate? It turns out German does have these, and yes, there are actually pink parrots. So Rosa itself has no case restrictions on it, similar to parrots. And so when you have find and help pink parrots, it looks basically the parrots part like find and help parrots, because pink doesn't have any requirements on the form. But you would think when you're going through this, obviously I laid this out as if it was really obvious and straightforward. When we were doing this, it was unclear whether we had really accounted for all of the examples. Would this really work? So what did we do to test this out is we actually created a very small grammar. It basically had one lexical entry for all the for a determinate noun of each type in each case, for the indeterminates, for the adjectives, for verbs which required various cases. We did very basic constituent and functional structure rules, enough that you could do only verb second. You only took a very simple object, but we had to do coordination, for example, in order to get the verbal coordination there. And then we went through and we took example sentences using these few lexical items for all the things that were supposed to be grammatical, supposed to be ungrammatical, ran them through our implementation to see whether it would work or not. And turns out it did. But as you work through all these things, you start thinking of other cases. What if you coordinate the nouns? What if you coordinate the adjectives? Does it in fact work? So this would be sort of the one thing I would suggest if you work in theoretical LFG or HPSG, you might want to consider, are you looking at an analysis that's complicated enough that you might want to pair up with someone, to test out how well that would work. Okay. So the next sort of use case I wanted to talk about is that sometimes when you're doing grammar engineering, you end up highlighting linguistic issues that often in retrospect you think are obvious, but that you hadn't really thought about how complicated these are before. Sometimes this just comes because you're having to implement every detail of the analysis, and you see where things might overgenerate and either provide multiple analyses when they shouldn't, or allow you to parse things that are ungrammatical. What's more interesting is often you're working on some type of natural corpus, which means you're seeing the interaction of various phenomena that it wouldn't have occurred to you that they interact with one another. And once again, there is a caveat that sometimes things may not be working quite like you think due to implementation restrictions. But in general, when you see things like I'm going to discuss here, it's very, very simple syntax, and you just didn't realize how complex it was until afterwards, when of course it seems obvious. And so I'm going to talk about copulas here. This is still hugely contentious in Pargram, but in particular, there is a paper that Helga Divik, Mary, and I worked on for this, and what we were really looking at, the part that I'm going to focus on here, is the second argument of a copula. Does it have a subject or not? And it turns out that this is very complex, and it's not just complex across different languages, it's complex within a single language. And as a spoiler alert, I do not have a good answer, so potential topic for a talk for next year in case anyone wants it. So why would you even think these things had subjects? You figure having an extra argument adds complexity. Why would you want to do this? In a lot of languages, predicate adjectives agree with their subjects. So I put a French example here where elle est petite, you have a feminine singular subject, so you have to use the feminine singular adjective on the predicate. And one way of doing this agreement is to have a subject on the adjective. So we'll see what that looks like in LFG for this. So you have your copula here. It takes a subject, which is non-thematic, which will become important later. And it takes another argument, which I'm going to call an X-comp here. The nice thing about X-comps is they have subjects. They're the things you use in, like, I want to go, to pass the subject from go and want. So if you have an analysis like this, what is really nice is that the verb be here can simply say that its subject is the same as its second argument's subject. And the adjective can simply say my subject is feminine singular. And so basically you just have feminine singular sitting up on the subject. We know the nouns are inherently have number and gender. And you don't have to say anything complex. The types of equations you see here are very, very standard LFG equations. Very easy and fast to implement. You see them in introductory textbooks. What happens if you actually don't have the subject there? You in fact get a fairly nice looking F structure here. We could discuss whether it's harder to see the connection between small and she, but it's pretty easy to read off for the semantics. It's not that difficult. But how do you get the fact that the adjective small has to agree up with its subject? It turns out that, okay, we'll see if I can use the pointer without causing, that you have to sort of write this thing that says, I go up from here, out of my pred link, through my subject, and look down in here to see whether you're feminine singular. Is this doable? Yes. I have implemented this. Many of the grammars have this implemented. It is doable. Is it pretty? No. Does it really, it's sort of hard to feel, is there much intuition as to why you should have to be climbing out and going back in to do this agreement? So you might view this as one of the reasons you would think the second argument happens to have a subject inside a copula, at least for adjectives. Another reason to think this is it makes doing raising adjectives have a very simple analysis. So this is things like it is likely to rain, okay, where the expletive it looks like it comes from rain, passes through likely, and becomes the subject. Or they are eager or loath to leave, where the subject of leave passes up through the adjective into the subject. And as you can see, you basically have a little stack of the subjects just going down through here. It's I did not show the equations. I figured it's early in the morning, and if you do LFG, you know what these look like. If you do HPSG, it's not going to be helpful in a 1-minute slide. But it makes it very easy to state that basically you're sharing this subject all the way down, and it's very clear that the subject is going to be licensed down by the lower verb, so that for something like rain, it's an expletive subject, which is why it's to the right of the angle brackets. while with something like leave, it would be a real thematic subject would have appeared inside the bracket. So it makes stating this very easy. Needless to say, it turns out when we were implementing these, we discovered there is a major problem, which is what happens if the thing that after the second argument of the copula already has a subject. So you see this in things like the problem is that they appear, or the problem is they're appearing, or the problem is for them to appear. And you look at this and you say, okay, if we're sharing the subject, which is the one in the upper left, it turns out that the lower verb ends up with two subjects. It ends up with the subject it should have, they appear, but it also gets passed down the subject of be, the problem, and this is a clash. Can you get around this? Yes, implemented that too. Is it ugly? It's so ugly I didn't even put it on the slide. And basically involves having to put an extra layer inside the F structure to sort of contain that second complement. If you have a closed complement, like the one down here, you don't have a problem because there is no subject sharing. Okay? So basically you end up with problem being the subject of be, they being the subject of appear, everything's happy. So basically now what we discovered when we were trying to parse real-world text is whichever analysis you choose, you have to do something odd. You either have to be doing these, for your standard case, climbing out to do agreement, or you have to do an odd analysis for the open complements. As you might be able to tell, I actually like the open complements slightly better, but not everyone does. So what did we learn from actually implementing these? So, we see that there are reasons on both sides for doing this, and we're only really looking, this is even just within English, okay? And unfortunately, there doesn't appear to be an overall elegant solution for English copulas inside of LFG. Maybe HPSG has a nice analysis of this. I'd be really happy to see it because maybe we can figure out how to use it. What Mary, Helga, and I argued was that minimally these things really do vary across languages. So for example, for Japanese adjectives, we don't think there even is a form of be. The adjective itself really is the predicate. So you really do need to look at your language for these things that appear to be copulas. And it becomes very glaring when you have something like Delphin or Pargram, where you're trying to build up fairly parallel constructions and you end up accidentally forcing Japanese and English to look at one another. We feel that's a space where it's just wrong. The syntax is truly different. Okay. The bad news for you is the examples are about to get more complex. And Miriam can laugh at me because we're going to be doing Urdu complex predicates, and I'm sure I'll say at least one thing that is wrong. And this is very technically complex. I've tried to simplify it here. If too many people look really confused, or raise your hand if you're so confused you need me to go back over something. We did have somebody mentioned complex predicates. I think it was yesterday. I will repeat what they are in case that wasn't enough to get them. But what we're going to talk about here is doing complex predicates via something called restriction, and I will mention what restriction is. So this is work that Miriam John Maxwell and I did, and has since been taken up in various of the implemented grammars. So complex predicates are very heavily studied in LFG. They're also studied in HPSG. They're extremely interesting because of their interaction between the lexicon and the syntax. Regardless of which of the frameworks you have, these pose a very serious issue architecturally for how you deal with this. It turns out that most of the ways that complex predicates are done in theoretical LFG are not possible in the implementation, but that you can do these via what's called restriction. And so one of the questions to ask once we did the implementation was, is this actually something you'd want to consider in the theoretical domain or not? So first, as a reminder, or if you weren't here yesterday for the talk, what is a complex predicate? So we have all the examples are going to be from Urdu. We have Nadia remembered the story here. The important part here is not any of the case marking or agreement or anything like that. It's really this part, memory do, which you use a noun and this thing called a light verb that combine to form what in English is a simplex predicate. So you really have what we will want to have in the functional structure of the lexicon is sort of this form where you've got a very simple thing, memory do, that takes two arguments, a subject and an object, very much like remember does in English, but you're going to have to compose it from this light verb do, which takes a subject and object, and this noun memory, which either can be sort of a standard noun with no arguments or a noun that takes an object. So the question to us is, how do we form these? Especially since they're productive, you do not want to list every single one of them in the lexicon, and in fact you can't do so because there are constantly new ones are being formed. Okay. So before we get back to the data, what is the restriction operator? So the restriction operator allows you to restrict out a feature from an F structure. It forms a new F structure that is identical except for the restricted feature. So we are not going around deleting things, that we haven't removed monotonicity from the theory. And this is going to allow us to dynamically compose predicates. But, you know, intuitively the idea is not that hard. If you have an original F structure like this one on the right, where you have you know, a predicate and number, person, and case, you could restrict out case and form a new F structure, no deletion guys, new F structure, that has the pred, number, and person. And so we had some discussion at the poster about the Greek clauses yesterday about whether if you restricted out case there, could you in fact have a simpler statement of what was going on. And restricting case was one of the reasons this restriction operator in fact was created. Okay. So, you know, in a sort of standard LFG analysis of complex predicates, what you want for remember in Urdu is something like this simple memory do, and we will not be repeating the discussion about the hyphens we had yesterday. We'll take that one offline. But you have this one predicate form, two arguments, a subject and an object. What we're going to have in the implementation using the restriction operator is in fact something that's formed on the fly, where you're going to have the light verb do as the predicate taking two arguments. One of them is the subject, and one is going to be this noun memory with its object. But what we're going to see in the F structures is sort of complex pred, so it really is a little more complex in that sense. But the F structure argument structure is exactly what you want. You've got one predicate, one subject, one object. Okay. So how do you do this? And yes, this does look complicated. There will not be a test. The F structure is going to be formed dynamically by composing the subcategorization frames we have for the light verb do and the noun memory. And we're going to invoke restriction on the C structure rules. So you have a simple, you know, this is basically saying a complex predicate is composed of a noun and a light verb. The little up equals down arrows just say it's a head. And in fact, both the noun and the light verb are heads here, but the noun, you restrict out the predicate. You don't actually pass its predicate up. You wouldn't want to do that because you're going to get a conflict between the predicate of the light verb and the predicate of the noun if you do that. Similar to what we saw with the likely example, or the problem is that, examples. And instead, what you're going to do is say that the predicate of the noun, so that's this one, is going to become the second argument of the predicate of the light verb. We will have a diagram. Okay. So do in the lexicon contributes basically its own little pred, the light verb do, a subject, and this sort of second argument that needs to be filled. And what that C structure rule you saw does is fill that second argument. Memory is just contributing its pred, memory, and an object. And so when you combine them, you actually get this predicate we saw before. Those rules are basically taking this and putting them into the second argument here. And you can, in fact, do that in the syntax instead of having to list these all in the lexicon. Okay. I tried to show this somewhat in a diagram. I don't know if this makes things better or worse. But effectively, this is what your noun looks like. This is what the verb looks like. And when you combine them, you'll notice that this here doesn't clash. Instead, it's been put into the second argument. And importantly, you get an object from here and a subject from here. So when you were doing that restriction, all the arguments of memory just get inherited. You weren't restricting out the arguments. So you could have something more, when you have verbs with other verbs for complex predicates, you can inherit very complex argument structure from that main verb, the one where our noun is. You'll see an example of that. Yeah, we will have time to see that. So what does this, when we implemented this, and trust me, it took more than 10 minutes to figure out how to do this, we ended up, there's some good things. It creates the predicates we want. It creates the functional structures we want. So this allows us to have an output of the Urdu grammar that has the functional structures we want and that are parallel to the types of things you would see in the German grammar and in the English grammar, which would be very good, for example, if you're trying to do machine translation across functional structures. It also allows you to stack complex predicates, because you can just have one more predicate on there, you do more restriction, you form a yet more complex predicate. Should this be used theoretically? It doesn't seem to have caught on. More people want to do it inside the argument structure, which is not implemented, but at least by doing this, providing these analyses out to the larger field, people can decide, is this useful or not? Now, as we'll see, there are actually, even though this was the only way to do this, there are grammar engineering challenges with this. One is it's a real hassle to maintain. I realize those of you doing the theoretical linguistics probably don't care, but trust me, it is really, really, really hard to debug this and maintain it. But it turns out there's an interesting architectural issue with lexical rules, and this is sort of the final area I wanted to talk about here, which is it turns out that all of these implementations, and I suspect this happens for HPSG, maybe this is a good thing for the discussion period, highlight certain architectural issues, because you made some decisions when you were doing the implementations having to actually parse everything out as opposed to just sort of thinking about it, even if you're thinking very carefully and writing a more theoretical paper. You see things that could go wrong, and then you have to think about, do you really have the right architecture or not? And it turns out this happened when we started combining passives with causatives in the grammars, and this happens both in Urdu and in Turkish in the pargram grammars. So passive in LFG is done by a lexical rule. We'll see what lexical rules are, but effectively you go through on the lexicon, run a lexical rule over every single applicable entry, and you get an additional entry. The causative is done by restriction. You can think of the causative as just being another type of light verb. Unfortunately, when we implemented this, we got exactly the wrong results, as you will see. Not just a little wrong, we're talking exactly wrong. So a little tiny background on Urdu causatives. Urdu causatives are morphological. They look basically like you would expect if you work on causatives. The causer is a subject. The underlying subject of the verb becomes an oblique. So if you have Yasin ate food, that's a standard transitive. You causativize it, and you get the causer is the subject, Nadia, here. Food is still the object, and Yasin, who was sort of the agent of eat, has now become an oblique. So this is not unexpected. This is a standard pattern for causatives. The analysis, which we will not go through in too much detail, basically treats cause here, even though it's a morpheme, we're going to treat it effectively with restriction as if it was a light verb. So for those who might care in the implementation world, what we do on the grammars is all these forms here, so this is an inflected form, will go to a base form, and then these little lexical items, tags, which tell you about it. So we know it's a verb, a cause, perfective, masculine, and singular. Each one of those tags with a plus has a lexical entry, just like verbs have lexical entries. And, you know, effectively we're doing sort of the same type of thing we were doing before. This, the cause, which you can think of as the light verb, is the head. This is also a head, but the pred itself becomes the second argument of the cause, just like we saw before. But importantly, the subject does not get passed up and down. Instead, the subject is going to become the oblique, I guess for some reason in the paper we called it an object goal and we called it an oblique, something which we should probably correct in the paper, Miriam. But basically you're going to say the upper verb has an object goal. Okay? And these eat looks just like what you think it would be, and the causative takes a second predicate and a subject. So what does this look like? We've got a very simple eat looks like what you think it does. The base is what you think it is. It's got the subject, the second argument. But when they combine, notice I put numbers here just to make your life a little easier. This subject here from that equation became the oblique. The object stayed as an object, and you get the subject from up here. So you combine these to get a single predicate that looks like what you want. Your F structure is what you want. So passives, in order to also, the ones we're looking at, look a lot in some ways like English passives. You take a perfective form of the main verb with this go, which you can think of as the auxiliary. The object of the base verb becomes a subject. The subject becomes an adjunct. So if Yasin ate food, you just get the food was eaten by Yasin. This should look very standard to everyone here. So what happens if you want to passivize a causative? So the subject of the causative is the one that becomes the adjunct. So if we have the A example is our standard causative. Nadia had Yasin eat, or Nadia fed Yasin. When you passivize it, the object, which is the food, becomes the subject. Yasin remains an oblique, and Nadia becomes this adjunct. And importantly, you cannot actually take the subject of the original verb, the one that's the oblique in the causative, and have it be a passive. This, if you thought about it, this is a very common pattern among languages. You also see it in Turkish. Unfortunately, the grammar had be here be ungrammatical, and the example down here be grammatical, which is exactly what you don't want. And if you think about the way we did these, it turns out this makes sense. So passives are done by lexical rules. For those who didn't look at the lexical rule poster yesterday, what does a lexical rule do? It does the same thing in HPSG and LFG as far as I can tell. Basically, you have something like, inside the lexicon, you have a transitive, looks like you think. If you call a lexical rule like passive, which you would call optionally, it just says, well, the subject becomes null, which is why you can then realize it as an adjunct, and the object becomes the subject. So you're basically, inside the lexicon, creating a second lexical entry. Why would you want to do this via lexical rule? You can capture generalizations that way instead of arbitrarily just having every transitive verb have two entries. That happens in the lexicon, which means causative applies second. So you end up with this ungrammatical derivation of passive and causative, where you have an original transitive predicate of eat, subject and object. You passivize it, so you get sort of this null argument in a subject, and then you do the restriction causative. And so what you end up with is basically having the wrong set of arguments with what becomes the subject here. And this is exactly what you do not want. It's because you already applied passive inside the lexicon, and then you later apply causative, means you cannot do the causative first and then the passive, even though that's in fact what happens in the language. How do you solve this problem? It turns out the only way we found to solve this problem was also to have the passive in Urdu applied via restriction, so it applies sort of inside the syntax instead of in the lexicon, unlike, say, what the English grammar does, which still uses a lexical rule. This adds to the grammar maintenance because you're dealing with restriction, but turns out it works quite well. So you start with your original predicate, same one we've got. You form the causative here. So you end up with, this is the subject that we want. This is Nadia, who's feeding Yasin. And then when you pacifize, you're pacifying off of what that causative subject is. So this is what you want to have happen. This works. In general, both the grammar writers and the theoretical linguists did not find it very satisfying. And I think the real reason for this is, at least in LFG, you usually think of doing these types of manipulations inside the argument structure, which is something that simply we do not know how to do this inside the implementations. The only way we can do that type of manipulation is with restriction or lexical rules. And we know, and we've seen how you have to be very careful about what you have apply as a lexical rule and what you have applied via restriction, because in some ways you can think of them as being ordered. This might be a unification formalism, but they are, in a certain sense, ordered, because what happens on the lexicon, once you have that lexicon, that is what you apply into the syntax. And so this is one where I think we really need to think about how should causative and passive really be? Is it that we are stuck in grammar engineering having these be via restriction inside the syntax, even though otherwise there's no reason to have passive done this way? Or is it that the theoretical linguistics approach is correct, and we may or may not decide to add it to the architecture of the implementation? So I think this is an interesting area where we really need to think about what we want to do there. Okay, so to sum up here, and yes, after the question period, you do get your coffee. I think it is really a strength of both of these communities that we have people very strong on the theoretical side, very strong on the grammar engineering side, and we have a lot of people who are seriously contributing to both parts of this, so that it's not that, for example, we have a whole bunch of people doing grammar engineering who know nothing about the theory, and many, if not all, the theory people are actually at some time or other at least had a graduate project working on the grammar engineering. And I do think we should work really hard on saying, when we're finding things inside the grammar engineering things, maybe it is things like the post-copular analysis, to be sure to bring that back into the theoretical literature, and to really think about, if you have some new analysis like the indeterminacy one, maybe you don't want to learn to use XLE. It's not trivial to do. It would take you time even to build a toy grammar. Consider partnering with someone who knows how to do this, to test that out, and you may discover new things, new sets of stuff that you hadn't thought to look at. So that's what I had to say. Thank you very much. Stefan, did you have a question? Are you moderating?
I guess I am.
Excellent.
I'm supposed to do something.
Thanks. Some pointers to other projects. So you forgot half of the implementing community of HPHD. So there's a project.
The other community.
There's a project called Program that does parallel grammar development. And it's more oriented towards the theoretical stuff.
Yeah.
So I think.
Happy to send me a good reference, and I'll put it in the written version. I do plan to write this up, by the way. I know usually the invited talks don't get written up, but my intention is to write this. So everyone, especially this type of thing, or more examples from HPSD like Bertold's I would love to be able to include references to places where people have been implementing in order to test out hypotheses, and they might grow into a bigger grammar like Bertolds have, but maybe you just did a fragment. I would love to have more examples like
Yeah,
that.
there's even a little indie grammar in this project. No,
It has not been
there's a...
vetted. It has not been vetted.
So there's an overview article on that in the Journal
Excellent.
of Language Modeling where I also compare the different groups, like
Yeah.
Pagram and the matrix and so on. Another point, so you said, okay, because you got the things wrong with passive and causativization, both of them have to be syntactic. So in earlier times
Yeah.
it was the other way around, that you said, okay, if I can show that one is lexical,
Yeah.
then the other one has to be lexical as well, right? And there's a paper by Manning, Zak, and Ida on Japanese causatives, and they have a section on passive, and it's done by lexical rules, right? So if you have the causativation as a lexical rule, as we do in HPHE, right? And they argue for that in this paper. Maybe
There was a
it's wrong,
reason they weren't done lexically.
You can't add arguments.
Right, so I think it's another one of these sort of implementation issues that maybe it's one of these ones that HPHD doesn't have, but LFG does. It's when you have to, for causative, you have to add an argument. In the lexical rules to figure out how to add, it's unclear
But you-
where in the predicate to put it.
But the Simpson approach to resultatives added arguments, right? So that is a very old...
I'm not saying it's I think most of the time the theoretical issue, the causatives are done lexically, but it happens to be that might be an interesting one to write up the details of, because it's very complicated to think about why adding an argument, it's really difficult to figure out how you shuffle these arguments, which in fact do have a reference and are numbered. You're actually referring to them by number. Does everything get bumped up a number? Do you want to add something, Ron?
Well, I don't think technically the problem is adding the arguments.
Go for it. You should get another one.
It's a free-for-all here. This is good. I was hoping this would invoke some discussion.
At least, from a formal point of view in LFG, I don't think the problem, even in the implementation, I don't think the problem is that you can't add arguments. The problem is conceptually, how do you interpret the arguments that you've added? So you don't want to just slap them on, add them on to the end of the list, because that's supposed to be a guide of what the semantics is supposed to be. And so you have to have some,
Right, you want to slap it onto the front of the list in this case.
Of cause and whatever it is, and then you have the internal predicates, so you're building up a compositional semantics. And slapping on an argument doesn't actually change the underlying predicates unless you have some other way of describing that on the fly.
HPHE has this argument structure list, so you can just add something at the
But what does that mean to add? Just, yes, you have
But you have the semantics in addition, and you have the right scope.
So if you had a
so
three-place predicate semantically, and you added 5 more arguments in the syntax, how do you interpret it? That's a question.
It's tandem. The lexical rule does the semantics. Once you apply the lexical rule, you're done. You don't have to worry how it's mapped to something. It's in the lexical rule, you have the causation operator that embeds the semantics of the other stuff. So you can have a complex semantic representation, but a flat argument structure it is. And so my poster on the benefactive construction is like that, right? So I add an argument in the middle between a subject and an object. I get a different pattern, like a ditransitive pattern, but I have an additional semantic component, and it goes hand in hand, and you can. There's a nice linking rule. So you said you cannot.
Right. I think this is the real issue: is that the linking component of LFG, which is a serious part of the component, and I had a poster on part of this. That part is actually missing, and so there'd be an interest in the semantics is done generally not via, as we saw anymore, via projection off. We tend to have moved the semantics either over into the glue semantics or into the transfer semantics, which has, let's just say it works but has no theory behind it, that you sort of lose this tie, and so it is a bit of a weakness of the implementation, but it really highlights by implementing it exactly how important this part is. So perhaps I should be the moderator since Ron has failed in that, and Adam can ask a question.
So one more point. So
Or Adam will not ask a question.
This and then the Copulas. So I agree on you that with you that it's important to implement that stuff,
Yeah.
right? And then you see the problems, and this is exactly the point about the program project, right? So we don't have these huge, large coverage premise, but we have phenomena, bizarre phenomena. So and it's really close to this theory. So to the Copular construction. So this is also there are several papers about this in HPC. And I think you try to solve the problem with one copula, and I think that may be the problem because there's an identification. Some people identificational, and some assume this raising version. And I think for German you need the raising version because there are all kinds of funny adjectives like subjectless adjectives and some with expletive subjects. So you want to get that relation somehow.
And I would agree, there are multiple copulas.
Right, as you have in HPC, the direct relation, there's no other way to do it.
Right. I think the existential is also one that's sometimes different. And so that was one of the things that's actually in the larger paper that Mary Helga and I worked on. Part of what we're arguing is within a language you may in fact end up with more than one copula. And the question I think then is controlling the ambiguity in the situations where when you're parsing something that looks very simple, you want to make sure you get the one correct analysis out.
So, Adam?
Question about restriction. So I'm one of the few apparently people that use restriction. In a paper with Agnieszka, we even have restriction in the title, but so it's in the theoretical analysis, right? Also implemented, but in the theoretical analysis. But I'm really worried about restriction because, as far as I understand, it creates a new F structure that just floating around, that's not connected to the overall analysis, and this F structure does not satisfy the various apparently very deep principles of coherence and completeness. So when you look at your slide 26, for example, what's happening here is you're creating
this one.
Yes.
Okay.
So the equation with the restriction is creating an F structure that's just like the F structure of the V light or N, but it doesn't have the pre, but it still has the sub. So that's violation of coherence and completeness. So that would worry me a lot, theoretically. Right?
Did you and Jürgen want to answer this?
I mean...
This is great. Good choice of chair.
Sorry about that.
So the question is, what does the restriction operator do when you restrict out something that's a grammatical function?
Yeah.
Right? And it doesn't make sense not to restrict out that requirement. I mean, that would be a useless operation. So in fact, the definition that we gave, I think, restricted out the government grammatical functions at the same time, so that it makes sense. Otherwise, it'd be pointless.
That's exactly what's happening.
Yes.
And I don't know about the implementation, whether or not it does that. I want to make one other point about lexical rules. Lexical rules are not recursive, so if you have positives or positives. Positives, you've got a problem. What?
You do.
So in LFG, lexical rules are not recursive, and that's an issue. It's about whether or not
you could make a second lexical rule that looked like
the syntax, not in the lexicon, and that's sort of.
Therefore, it has to be in.
So that's an issue.
So from the other side of HDS3, so I leave it, Stefan, doing the semantics or something like the onto applicatives, positives, passive. That is straightforward in HDS3. You just embed semantic structures under the, you follow the mirror principle that you have in that. But the light verbs, that is another question. So here I feel that LFG is sort of a bit flat-footed imperialistic in saying that when other languages do things periphrastically, you have to translate that into something which is a good English predicate.
But the light verbs, I mean, as far as I understand, and Miriam, feel free to chime in, but these light verbs, it's not that we're forcing them into the parallel grammar context. This is what you want, and the question is how to get there, both theoretically and computationally, that this is not about forcing parallelism the way when we originally did Japanese adjectives and tried to force them to look like English and French adjectives, that this really is what you want, and the complexity is in how you take this string that looks paraphrastic and get the functional structure or the semantics that you really wanted underlyingly.
And you will have paraphrastic constructions that look similar that are bicausal. So not everything that is paraphrastic has to be in one thing. And that's, I think, where LFG and HBSG actually differ in the theoretical analyses a lot, because there's finer distinctions being made here.
Okay, yeah. So I'm curious to see how we can do lightweight constructions in HBSG, actually.
Right. Maybe talk to Miriam. Yeah. But there's definitely work on it. Okay. Shall we diversify the question base here?
Thank you. I have some more input for the written version.
Excellent.
So this distinction between open and closed
Yep.
complements is something that I started from when I did
Excellent.
work on copular constructions. It's just that I extended a bit, not only looking at the copula be, but all of the other verbs that can appear
Right.
in that kind of sort
Yeah.
like become and remain,
That's right.
seem, and there's a,
All the secondary predicate
yeah, right,
ones.
yeah. Both the subject-oriented ones and the object-oriented ones. And it turned out that the closed complements, so the ones that are really a problem for the subject-raising analysis, and also for the small clause analysis
Right.
of transformational
Yeah.
grammar, by the way, are actually very common, because if you define closed complement as something which does not share the subject with the subject of the copula, then it turns out that you do not only have clausal complements, like the example
Right.
you gave, you also have gerunds, like the greatest pleasure on earth is drinking champagne and eating
Yes.
caviar. It's not a pleasure that is
Right.
doing eating or the drinking.
Yeah. I think I
That's
had
like
one of the
arbitrary
gerunds in
throw
there.
And,
Yeah.
So that's another case where subject rating does not work. Still another one is two infinitives. The problem is to leave in time. So
Right.
again, arbitrary throw.
Yeah.
And then you have deverbal nouns like this is our worst fear. So we are the ones that do
Yeah.
the fearing, and not this is the one doing the fearing. So all in all, I did some corpus-based research. I found out that nearly half of the predicative complements are closed,
Yeah.
and hence problematic for the subject
Yeah.
rating analysis. And so in the meantime, I finished a book on it. It was published last year.
Excellent. I'll have an up-to-date
I'm not going to
publication.
summarize it here.
Perfect.
It's just something.
Yeah.
So maybe one more and then coffee?
Okay, so this is...
Unless it's a really good one, we're going to talk for half an hour about it.
It's a very general issue, I'm afraid. So,
About what? I just...
okay, so your talk is about the kind of connection between theory and implementation, right? How they kind of reinforce each other. And here, I think HBSG and LFG differ really a lot, right? And that's, I mean, one of my kind of problems with LFG, and I've been doing that for many years, well, some years now. Namely that, in HBSG, you have this underlying logic, right, which is well defined apart from implementation, right? So this, so any analysis I can, axiomatize, and then, I can kind of formally see what the kind of inferences are, etc., etc. While in LFG, it seems to me that, not so much work has been put into, really defining the full logic of, what F structures mean, what the full analysis mean. So it happens to us quite a few times in Agnieszka, especially at the beginning, that when we were asking some kind of detailed questions about, what does this really mean, we were sent to bigger and bigger people in LFG, and finally we were getting answers, well, check the implementation, right? It will tell you what it should mean. And we still don't know what it means to unify two sets, for example, right? So, I'm not sure whether this is really a good thing about LFG, to be honest. On the one hand, you have very close implementation and theory, so that's something that's a problem for HBSG, because there's this nice theory, and then implementations tend to be kind of a bit far from it, right? Some are very far, others are pretty close, but still differences.
Okay.
Like in LFG, there's full unification, but maybe I would like to have this logical.
Well, so I would deny the premise. I think that LFG is actually very well formalized in a model theoretic sense, and that was true in 1978.
Yeah, but there were lots
And the
of
structures
mechanisms
are well
added since then.
defined. So the implementation, there's certain special features of the formalism that have, like distribution over coordination, for example, and the interaction of functional uncertainty. The interaction of functional uncertainty with distribution are actually, specially defined. They are well defined, but specially defined to correspond to the way languages actually work, as opposed to the way algebra might work in other ways. So about, what's narrow scope and wide scope and so forth. It's very, very well defined. The implementations for some of these things are trickier. Either because, you're making an approximation for efficiency or for some other complexity reason. So that's where, there's sometimes a slight disconnect. But I think, for example, if you read Mary's book, has fairly well documented almost all the properties and motivation for them that have been collected over the years.
It's an excellent book, but it's not a kind of fully logical theory like, with all the axioms really set out explicitly, etc., right?
Well, that's style, I think, more than substance. And I know in HPSG, there's a difference in strategy in the way the theories are set up. I think, in HPSG, a lot more is done in the uniform representations, in the feature structures and all the properties of feature structures, and so forth. And a lot of generalizations are coded by putting things in the data, whereas in LFG, a lot of the generalizations are coded in the operators in the algebra, like functional uncertainty, for example, as opposed to having slash and doing all that stuff kind of up and down the structure. In LFG, there's a constraint that you don't actually see its effect in the structure going up, but you see the input and the output relationship. So there's a difference in style where in LFG, things that may be difficult to represent as types and as feature values and so forth that you can visualize are actually in an algebraic system that has satisfiability relationships to structures. So I think it's a difference in style there, but I don't think that the difference has to do with whether one is more formal than the other.
Okay, taking back my chair activity. Thank you all.
So Tracy, thank you.